Good morning. Happy Friday, everyone, and to another session of Azure Power Lunch. Uh, Manoj Raheja from the product team is going to be talking about Azure Data Explorer. Manoj, floor is yours, man. Go ahead.
Okay, thank you. Good morning, good evening, and good afternoon, everyone. This is Manoj Raheja here. I'm a product manager with Azure Data Explorer team. Today, I'm going to give you a quick overview of the service and we'll go through some demo. At the end, we'll keep about 5 to 10 minutes for any questions. And let's get started here. Uh, Now it is my desktop visible.
Yes, sir.
Okay. Okay. So let's get started. So, we all know when you're collecting data, the customers want to take actions on different type of, data has been collected. For example, if you're looking at clickstream data, I want to understand why visitors are abandoning shopping cart, or you're collecting data for an IoT devices, you want to understand how the device is behaving, when it was down, when it was up, and what's the performance, when it's going to fail. So there's been a lot of data being collected, and want to get new insights from the data. We want to freely explore the data unconstrained, and moreover, we're seeing more and more real-time scenarios where you want to know what's happening now. There are traditional systems where you collect data, then you go through ETL, and then the data is available after a few hours and so on. But what we have been targeting here, or talking about here, is getting near real-time insights where you're looking at data which is as soon as it's been born, as well as little processing as required for the data to explore. So real-time use cases are across all industries: oil and gas, retail, finance, advertisement, media, and you'll find different scenarios across different industries here. From Azure, we have something called real-time pattern, which identifies these couple of services which can be used in combination to build those kind of real-time patterns. One is IoT Hub, Event Hub as an ingestion point where you ingest data from multiple sources in real time, and then use Azure Data Explorer or Stream Analytics or combination of those for building a real-time pipeline. You would use Stream Analytics if there are scenarios where you want to do a continuous real-time analytics in a moving window of data, and Stream Analytics doesn't persist any data. It holds everything in memory, and then processes as the data comes in, and then spits out the data into the destination. And Azure Data Explorer, on the other hand, is an on-demand interactive real-time analytics on your streaming data. So think of data has been streaming in. We are persisting the data. We are caching the data on disk in memory and making it available for interactive query, for operational analytics, and so on. So customers build dashboards, alerts, all sort of automation, manual reporting, ad hoc exploration, all on this on our platform. And the data is persisted. Customer controls how much data you want to store, and how much data you want to retain, how much data you want to cache, and we all manage it for the customer. We'll look at it in details. So at very high level, Azure Data Explorer is an interactive analytical service for fast flowing data, helps you cut down time to insights, get real-time insights on your fast flowing data. It's a fully managed service. It's a Azure PaaS service. We have auto scaling capabilities. It's maintenance free indexing. Many of the databases, as it grow, it needs a lot of maintenance in terms of indexing, and also you have to go fine tune the indexes as the query pattern changes. Whereas in Azure Data Explorer, once you create table columns, all columns are indexed by default and compressed by default. So absolutely no maintenance required on that front. And we enable data-driven culture through entity query language called KQL, Gusto Query Language, and we'll look at it shortly. So Azure Data Explorer is a proven technology. It's been there since 2015. We use it internally, called Gusto, and we went GA last February with the same service. So pretty much, all internal services, internal to us, but actually these are services that you have been using it from Microsoft, including Skype, LinkedIn, Bing, Xbox, Azure, or Windows, Office, and so on. They all use our platform for doing telemetry analytics on really, really large scale. We ingest petabytes of data every day on thousands of clusters running this workload. We also have other SaaS solutions from Microsoft, which are built on our platform, like Azure Monitor, App Insights, IoT, Central IoT Time Series Insights, PlayFab, other security products like Azure Security Center, and so on. They're using our platform as their warm store in the backend for this platform, and this is the same service we have been exposing to customers. So this is hardened from many years, and at a very good maturity, which was launched last year, and it's the exact same code base, no difference. And the service was born in cloud from day one, so it's designed for cloud kind of workload. So common use cases for Azure Data Explorer, or if you have data like time series, logs, events, transaction data, and you want to do perform analytics on top of that data, Azure Data Explorer will be the good best product for this. There are various scenarios you would like to do. You want to consolidate and correlate your logs and event data across different platforms. It could be on-premise. You want to bring in data from on-premise, cloud, third party, and so on. Replace log search solutions, like you want to save cost, or you save on infra, you save on index maintenance and other things. And accelerate your AI ops journey, doing pattern recognition, anomaly detection, forecasting, and bunch of other things, or implement IoT analytics, and do some time series and telemetry analytics. One big advantage that you get with Azure Data Explorer is, typically customers have been using two different platforms, one for time series, one for logs, and then sometimes it becomes very hard to like correlate and and use them together. And there are scenarios where you get logs and you have to generate time series data out of that. Again, that's a challenging. Then you have to use a third platform to actually build those analytics. Whereas Azure Data Explorer is very powerful engine that is optimized for running queries over unstructured data like logs and text data, and semi-structured data like JSON, and structured data like time series. So you can bring all that together. Um, Sorry, is there a question? If you're not talking, please mute yourself. We'll take questions at the end of the call. Or there are scenarios where customers want to build SaaS solutions on top of our platform. Like Microsoft has been using our platform for building SaaS solutions. Azure Data Explorer has been, built in such a way that it's an ISV friendly. All our toolings are open. There are some tools that you can just use it, iframe and so on. So you can build rich SaaS solutions on top of that. And there are some scenarios where customers would like to bring in temporary environment for doing analytics, and shut down the environment when they don't need it. So where do you fit this in your data lakes analytics? So typically you have data coming in a batch mode, or a real-time sources, and it goes into a data lake, and then you build your data warehousing on top of that platform. Azure Data Explorer kind of fits in here, where you store moving window of data from days to month. So this includes all the data that's coming in real time, as well as all the data that's already arrived. And you determine, hey, keep 30 days of data in my hot cache, so it's available for faster query performance. It's all raw data, unprocessed data, and so on. And you do real time. It's real time. It's cached, index for faster query performance. So there are two ways to bring data in. One is through streaming mode, through Event Hub, IoT Hub, Kafka. Event Hub, IoT Hub, we provide a native integration. Uh, and Kafka, we have a connector through which you can push data into Azure Data Explorer. And we also have an export capability through which you can export data out to data lake, and then hook up rest of the other systems to that data. There is also a way to get data in batch mode. We have ADF connector that helps you bring data from many different sources, including on-premise, as well as other SaaS applications, as well as we have a deep integration with the Blob and Data Lake to bring data from those systems. If the data is arriving in a batch mode, we can do a batch loading into Azure Data Explorer and cache it, index it, and ready for query. So you can do it automated, or you can do using our SDKs and so on. So I will get into demo. I just want to quickly show in high level how Azure Data Explorer looks. So Azure Data Explorer is a cluster base. So you create clusters, and these are absolutely PaaS service. You don't have to manage it. You don't have to log into the machines and so on. All the interaction to the cluster is through APIs. We expose two type of APIs. One is the ingestion APIs, and the other one is query APIs, where you can query data. So at very high level, when the cluster is provisioned, we provision data management nodes, and we provision engine nodes, minimum 2 machines each. And there are different various compute options that we have, starting of dev test queue, which is under $200 a month. And then another one is $600 a month, and so on. And then it all goes up to like 5,000 or so. So you need minimum 2 nodes. You can switch between different compute layers, and we take care of automatically moving, recaching the data, and we have auto scaling and so on. So it helps you to scale your cluster based on different parameters. And all data that is ingested into the platform is sharded and distributed across different nodes. So when you run queries, it really runs really fast. And we provide built-in integration for IoT Hub, Event Hub, Data Lake, and Blob Storage. Plus, there are all these different connectors that you can use to bring data in. And on the consumption side, we provide some built-in capabilities like web UI, desktop tool that to interact, do ad hoc queries. And then you have APIs, SDKs, and all the different connectors that you can use to access the data. Okay, let's. I can take quick 2-3 questions and then move on to the demo.
Can we build real-time streaming applications based on the data? So we are consuming the data to ADX and then Power BI or any other dashboarding for the real-time streaming?
Yes. So the data is arriving, you can use Power BI to visualize that data. You can use Grafana to visualize that data. We don't push data to Power BI and do a real-time dashboard updates. Is something that Power BI has to refresh. You have to set a refresh interval on Power BI, even Grafana, to run queries against our database and then pull data from the database.
Thanks, Manoj. So does it support the direct query from Power BI so that what are the changes? Yeah, okay.
Yeah. We support direct query as well as import. Both options are supported.
Yeah, great. Thank you so much.
Thank you. Okay. So as I mentioned earlier, platform is optimized for 3 different type of workloads. One is you have time series data. The other is you have semi-structured data in a JSON format, and unstructured data. Specifically, I'm talking about logs. So doing searching through the logs, doing regex, extracting some relevant information from the logs, creating time series out of it, and so on. So I'll start with the time series demo. So in this case, these are my clusters I've connected through our web UI. And again, there are different options that you can connect to. The way you would do is first you is create a cluster. So go to Azure portal and then create Azure Data Explorer cluster. You specify, region and which compute you want. So this is my demo cluster where I'm using a compute called, D13V2. And then I have 2 nodes in my compute, and I can I can pause the compute here. Basically, you stop the compute, it will stop the billing. But the data is still persistent on the storage. So when you start the compute back, we can again recache and make the data available based on the policies. So once the cluster is provisioned, you can go access it this way. You can scale up, as I mentioned. You can switch between compute as your workload changes. And also you can scale out. There are different options that you can use. You can manually scale out, use optimized auto scale like Leave It On Us, or you can go use custom based, metrics based auto scale. We expose bunch of metrics on the cluster, like what's your utilization, cache utilization, how much ingestion you are utilizing, and a bunch of things. So you can set metrics on these ones and then make a decision to auto scale. All the enterprise capabilities are built in. For example, you have to enable encryption at rest and so on, or or host this cluster in a VNet. So all the major enterprise capabilities as any big customer would like to in order to get to production, those are all being implemented, and we are present in all regions, including government cloud. So once the cluster is provisioned, you basically go and create databases, and on databases you go create tables. And as I mentioned earlier, we provide this deep integration with Event Hub and storage. So here, once you go to the database, you can go and add an ingestion pipeline. You can say bring data from, let's say, bring data from IoT Hub. and then specify the details for the IoT hub, specify which table you want to send to, what kind of format it is, and we'll take care of reading data and pushing it into the platform. And we have different knobs that you can use, right from streaming, which is a couple of milliseconds to under 10 seconds latency, all the way up to like 5 minutes to 15 minutes, 10 minutes latency, depending on the data volume, format, and how much you are willing to spend. You can fine tune those knobs and use the right settings. Now let's look at some example here. So I already have a cluster called Ignite Source, and I have a bunch of databases building. So I'm going to focus on occupancy database, and I have these different tables that I've created, and tables have columns. And I can also create functions, store the functions. These are like views or store procedures in terms of SQL. And then you call them in my code. So this example uses thermostat data. It's a simulated data that every 30 seconds I'm getting some thermostat readings. Now I want to go and analyze this data. So let's look at one device. So in here I'm using query called KQL. And when you're interacting through our UI and tools, it has full IntelliSense support. So let's say you start with the table name, pipe it, and then start writing query. This is the same language which has been exposed through Azure Monitor, Application Insight, and Sentinel, and so on, even Windows Threat Protection. And there are other products that have exposed this same language. So you can just start with the table name and start writing the query. Let's say device ID contains, and something, let me see, and just you can start writing. So in this case, I have starting with the table name. I'm filtering where in queue time is greater than a go 7 days, is I'm saying give me all data for the last 7 days for this device, and generate a summarize average temperature by 1 minute window. So now let's look at, now ran this. This is a summarization of 1 minute window. But if I want to change the resolution, it's so easy. I just change it here, and bin is it the 10 minutes resolution, 15 minutes resolution, and on the fly the queries run really fast. Then let's say this data looks very consistent. You cannot figure out if there is a missing data or not. So we have capabilities like make series, which helps you to convert any kind of data set into a time series data set, which will create standard buckets of data and figure out if and then mark the data as 0 if the data isn't there for that specific time frame. So we're going to use that now. It's the same query where we filter by 7 days device ID, and now here we are using make series, and then we want a window of 1 minute bucket. And let's see now. So immediately we see that there's missing data, and let's look at the table view. So this is my consistent time frame every 1 minute and the corresponding data, and you can see zeros are here. So it didn't find any data for those windows. Very common in IoT scenarios. Then you can go fill those data. So it's the same query, just adding additional capability like series fill linear. Now I can detect that there's a missing data and then fill that with linear interpolation. And there are other options you can use here as well as build backward, forward, and so on. Now these are like a basic capabilities. Now let's look at some advanced machine learning stuff. So now I want to go and forecast temperature for the next 15 minutes. You can just use built-in capabilities like series decompose forecast, and then it will detect the seasonality in the data, and then depending on that, it'll figure out what's the forecast based on seasonality, and you can fine tune that as you need. You can also do anomaly detection on the data, and detect if there are anomalies, and these are all using built-in capabilities. And you can do single time series anomalies on a single time series or multiple time series in the same query. It runs in distributed across the nodes. Finally, I'm running anomaly on all my devices, finding out the anomalies and then pulling that in. So this was a quick demo on time series data. Now we understand that this capabilities may not be enough. You want to bring in some custom code. You want to use open source stuff. So for that we have integration with we have integrated Python as part of the query. It's an inline Python, also called Python plugin. So in that case, you can bring in your Python code and run it as part embedded into the query. So in this case, I've created a function, stored function, to just simplify my query, and I added my Python code. You can write a Python code here, or you can give a link to a Python file. and I've just embedded my Python code, wrapped it as a function. And in my query, it's a similar query here. I'm going and querying last 3 days of data, and then passing the data to an operator, to a function that I wrote. It's a user-defined function, and then querying that data. So in this case, it's spinning up the Python sandbox on the nodes, and then it's going to run this query, get the data, send it to the Python engine, and then query it. Um, so this is all data that came from my database, and this is the clustering. This is the data that came from the Python execution. So in this case, we ran k-means to cluster these devices into different clusters based on their behavior. I can also bring in a custom machine learning model and host that. Again, you can serialize your model, store it as a string in the database, or you can give a part to the model. And in this case, I've stored that model as a string in one of the table. And during runtime, I load the model and then run my scoring. So again, this is I've created a function, a user-defined function, and in my query, I'll call the function. In this case, it's going to load the model, send the data, run predictions, and say give me the data. This is all running on the same compute node where the data is, and it just did a prediction here whether the room is occupied or not based on the temperature and other parameters that I've sent in. So this is all around time series and how you can evolve around doing some advanced analytics on there.
Is there limitation on the size, Manoj, on the data set size? Is it terabyte is different in performance as opposed to GBs of data, or is it relevant at all when you train?
Yeah, definitely. So we recommend you training outside. Use Jupyter or any Python engine, or use Spark engine. Train the model, because in general, for training you need a lot more data, and you may not have it here. And then once you're done training, you can get that model and deploy it here. And as the data is coming in, you can run those operations on top of this. We do have limitations on the queries on how much data you can. There is no limitations on the query, like you can go query like terabytes of data, and I'm going to show a next demo. But the result set has limitations around 500,000 records or 64 MB. And those are soft limits. Again, you can fine tune it, but if you increase those limits, then you have to consider how you're going to manage the concurrency and multi users using the same resources. There are a lot of different parameters it comes into play here, the size of the cluster. So it's all documented. So in our here, so go to the documentation and
oil and gas is a lot of data, which is in the lake, and there's close to hundreds of terabytes. So that's why wondering how it will perform and how do we train these things. So.
Yeah, sure. So these are all documented here. So look for query limits, and it explains you all the limits that you have on the query side. So those same limits will apply here as well.
Okay, thank you.
Yeah. So there are different pieces in the limits. There are limits everywhere, but there are soft limits and hard limits, and we can fine tune based on the scenarios. Okay. So we have just 5 minutes. Let me quickly show 2 queries, and then it'll open up for questions. The other scenario I want to point out is this is another data set, which is about 41 billion records, 41 billion records, 30 terabytes in size. And in here, you can see I can run, I'm running queries just on the fly. This is aggregating 800 million records in just under a second. The key thing I want to show you here is I'm skipping through some queries, but I want to show you some capabilities around text search. So this is a scenario where I'm a DevOps. I have a lot of log data, and there is unstructured data, traces in my trace logs in my data. I want to extract some information from the traces, which is completely unstructured, and then do aggregations on top of that. So in this case, I have the base query defined. I'm using let statements to make code more readable, and then filter data by event text. So I'm just doing a free text search here. Event text has some string, and then doing a regex to extract user ID, and then doing self join and aggregations on top of this. So this just ran within like 1.5 seconds. So you have 41 terabytes of data. We filtered it for a specific date, so we can do very, very efficient index. We have very efficient indexes to get to just the right data and then run those queries in a distributed way and bring it up. So that's a quick thing, do explore do look at our documentation around, doing text search. Is a lot more capabilities that I can show in in 5 minutes. The other capability I want to quickly introduce it is around on semi-structured data. So if you have a semi-structured data like this one is this data is about let's say sample 10. This is all the semi-structured data where I have different events from GitHub public repos or when people are using them. So there are different type of events, and every event has a different structure. So these are all data stored in a JSON format. And this is we call it as data type as dynamic data type. So you can create table with a dynamic data type and store JSON is it, or you can store arrays as well. So the JSON is stored in a native format, and I can just run queries on top of that. In the interest of time, I'll just switch to one query here. Let's say I want to go and understand all the repos that Microsoft has in open source and get top 5 repos by the event count. So I'm querying my table. I'm saying repo.name. Again, the repo is here, and I'm querying repo.name. And has Microsoft, and then doing a count of repos by repo name, and then getting top 5 repos. So let's run this query. So this ran on 1.2 billion records in 600 milliseconds, and I have my top repos. So I went through repo.name. I can also just query on top of the whole column itself. So we index JSON. There are two type of indexes we create on JSON data. One is on the string, the whole column, as well as we have additional inverted index on the string, as well as some additional indexes on the JSON, so we can navigate through the path. So again, we can only show limited things in on this call. I highly encourage you to go through our documentation. Go look for Azure Data Explorer documentation. I have another video here, and there are a bunch of tutorials that you can go through. There's how-to guides. It explains you how to bring data from different sources, step-by-step instructions, examples, a lot of content on this site. So with that, I'll stop here and quickly take any quick questions.
Is there a sizing for the cluster size that you need to select? You said 2 virtual machines, right? Do you go higher and scale?
Yeah, definitely. So let me quickly take this. Okay, maybe we'll send you the deck after the call. So okay. Go to akms/adx.cost. This is our cost estimator, and I'll paste that in the chat window as well. Okay. So go to that site, and this is a calculator where it helps you to estimate what capacity would you need, and all the RI pricing, and also you have to edit. There are instructions on the bottom how to use this sheet, but in general, you would go and add it here. Let's say you want to bring in 5 terabytes of data every day. You want to keep data in hot cache for 7 days. You want to retain data for 30 days. Maybe there are scenarios where you want to go and query data from the cold store. So we keep data in the cold store, and estimated compression. Fill out the region that you want to go to, and then it computes it'll tell you how much capacity you need. So you can run this workload on a 2 D14 machines with 4 terabytes. So there are different machines that you can choose from. And so we'll automatically select the lowest offer that we can give on this one. But if you need more high power computing, then go switch to D14, and then you get a different price. You go to D16, you get a different price. So there's a huge price variation depending on your workload. Some workloads are a lot of data but less query. Some workloads are less data, a lot of query. So you may have to pick and choose. So this calculator will help you determine what capacity you would need, minimum capacity you would need for a certain type of workload. And we also have pay-as-you-go pricing, 1-year RI, 3-year RI, which are pretty attractive discounts.
Okay, thank you.
Any other question?
Yeah, Manoj, if I have an option of selecting ADX versus Synapse versus PostgreSQL. So do you think all 3 options in the same use cases, or can you kind of help us differentiate between these three options?
Yeah, they're different use cases. Postgres, I would categorize that as an operational database where you would build your applications and do, if you know, uh, when you're building application, you need some operational database. So I would say Postgres fits into that. People do run analytics, but then you need a lot of compute, compute to run same type of analytics. And also there is any relational database, it has all the maintenance requirements and so on. So Postgres is mostly on the operational analytics. On Synapse side, it has SQL pool and Spark pool. SQL pool today, that's a data warehousing. So again, those are different scenarios, different use cases. Ours, Azure Data Explorer, is mostly targeted for log and time series scenarios. This is an append only store. You cannot go and update rows. You can delete data for GDPR compliance reason. It's a pretty heavy operation, but it's an append only store. So that way you can make a decision, what type of data you have. So that makes this offering very attractive for logging, clickstream data, event data, transaction data, time series data, because you don't change those data. Those are all data that don't change, and they are append only in nature. So it makes it really easy to use our system with that kind of data sets. So these three technologies are different, and they are catered towards different scenarios.
Thank you so much for clarifying.
Yeah. Any other questions?
Over time. Thank you. Thanks, Manoj. Okay. I know we are a bit over time. Thanks for staying. And we will share the recording. And Manoj, if you can send me the presentation, I will upload the PDF as well.
Sure.
Yeah. So
I'll send
thank you very much.
Yeah. Thank you.
Thank
Bye.
you. Thank you very much. And have a happy Friday, everyone. Stay safe.
Yep.